Good afternoon, everybody. Today, in our run-along linear relations, we're going to look at the Gradient-Intercept form. So this is just a particular form that our equation takes, and it helps us in one way to draw the graph. So jumping straight into it, our first thing is going to be to identify the gradients and their intercepts. So for these couple below, we want to state the gradients and the y-intercept for the graphs of the following relation. So these are our relations. Okay. Some people might have called them equations in the past, and we want to find the gradient and the y-intercept. Now this is generally pretty easy because in this form the equation literally gives you the gradient and the y-intercept. So the coefficient of x, the number in front of x, is always the gradient. Okay, so it's always the gradient. Now that in our equation is given the letter m quite often, so you'll see it stated as m, and there we can see that the gradient is equal to 2. So that means that if the gradient rise over run, that every 2 our graph goes up, it goes across 1. Okay, so that tells us the rise in particular in that case. Over here, that there is our y-intercept. Okay, so that is we call that the constant of the equation. It's on its own, it doesn't change. So our y-intercept is 1 or plus 1, because sometimes we can have a negative y-intercept. Okay, now this one here can take the form of c in our equation. Okay, so often we'll state this equation as y equals mx plus c, where we need to know m and c to be able to draw the graph. And in this case, the m is 2 and the c is 1. On to our second equation, and gradient and y-intercept. Small change in this one. In here, you can see we've got a coefficient of x. That's going to be our gradient. So let's put that in as -3 this time. And over here, there is no stated y-intercept. Now that doesn't mean that the y-intercept isn't there or doesn't exist. Okay, what that means is the y-intercept is 0. And if it's 0, that means that our line goes through the origin. Okay, so our line must go through that point. So it could go like that, or it could go down like that. Okay, but it has to go through there because the y-intercept is 0. All right. Okay, let's cruise on down to the next problem. And we look at rearranging equations. Okay, so here we've got two equations. In the first one, we've got it stated in the intercept form. Okay, call it the intercept form. So 4x plus 2y equals 10. And it wants us to rearrange it into the form of y equals mx plus c. All right, now if you're asking yourself, how do you do that? All we have to think about is we need y on its own. So it means using our algebra, we need to get rid of the 4x and the 2 there. Okay, so if we take that over here, 4x plus 2y equals 10. Okay, first thing we want to do is add or subtract stuff to get rid of it. Now we want the 2y to stay there at the moment, so we're going to get rid of the 4x. Now that's a plus 4x, so what we can do is subtract 4x from this side, and also we balance it by taking 4x from that side as well. That'll leave us with no 4x over there. And when we go down to the next line, we keep our 2y. And then we've got 10 minus 4x. And next step, we can see that 2 is multiplying, or y is being multiplied by 2, and the opposite of that is to divide. So we're going to divide that by 2 and divide this whole side by 2, not just one part. Okay. So when we divide that, we're left with that one, and we get y is equal to, so 10 divided by 2 is 5, and -4x divided by 2, well, 2 2's go into -4, so that will be -2x. Okay. Now you can see here we've got our coefficient of x and the variable on the right hand side and the constant 5 on the left hand side. We want that to be swapped around just to show it like that. So what we'll do is state it as y equals negative 2x, because that's our gradient and variable, plus 5, okay, because in front of that 5 is a plus. And there we've done it right there. Our next one asks us to go from the y equals mx plus c version of the equation and put it in the ax plus by equals d, which is what that version is there. Okay. So to do that, we are going to simply try and get our y on the other side of the equation and swap the 7 over, or you could move the x as well. So let's have a look at one way to do that. So y equals 4x minus 7. Now I can, as I said, move this to the other side. So let's subtract 4x from both sides. So they will disappear and we'll get negative 4x plus y, because it's a positive y, otherwise it would have a negative in front of it there. Take 7. Okay. We can either leave it as a negative here, or we can get rid of the negative and divide this side all by negative 1. Okay, so if we want to get rid of the negative, if you're asked to leave d as a positive integer, then we can do this. So minus 4x plus y equals negative 7. So the opposite of, to get rid of it, we simply divide by negative 1, divide this side all by negative 1, and end up with basically just swapping the signs. So we get 4x minus y equals 7. And that's our moving from the y equals mx plus c into the ax plus by equals d version. Okay, last but not least, sketching using our gradient and intercept form. So we've learned how to sketch by finding 2 points of the line and putting it into a table and that sort of stuff. Now we want to use the gradient and intercept of the relations and sketch their graphs. Okay, so first off, easiest way to do this is to start with our gradient intercept. I'm going to do these both before I sketch them, just to make sure I put the right scale on my graph here. The gradient equals 2 and the y-intercept equals negative 1. So as before, you can see that there. And then over here, I'm going to put this into the y equals mx plus c version of the relation. So I'm going to get the x over here. So if we take x from this side and take x from this side, they will disappear. So 2y equals 6 minus x. Then divide it all by 2. Okay, so that will be divided by 2, divide that by 2. So they cancel to give us 1y. And we get 3 minus x over 2, or x is a half, I guess. Half x is the same thing. Now I'm going to switch that around so it's in our intercept and gradient intercept form. Okay, and our gradient and intercept for that one is intercept. Okay, so y is obviously 3. Now I'll show you that x is the gradient is half, so or negative half. The same, we can express this as negative 1x over 2. Okay, and that is effectively the same as saying negative a half x or times x, because negative a half times x, if we put x as a fraction, anything as a fraction is just itself over 1, so x over 1 is the fraction. Okay, So if we have it like that, then 1 times x is just x, and 2 times 1 is just 2. So we end up with x over 2. Well, our negative is obviously still there. Okay, so you can see that hopefully the link between that and the fact that our coefficient of x is a half. Okay, so for that, or negative a half, I keep saying a half. Okay, negative a half. Okay, so now let's plot these. So the first one, let's do that in blue. So we want the y-intercept. Let's put some marks on this first. So the y-intercept, let's go up in 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so the y-intercept is -1, so that's down here, -1, and the gradient is 2, so that means that every 2 it goes up, it goes 1 across. So 1, 2 up, 1 across. That's a rise and run of 2 over 1. Once we've got that, we can plot our, whoa, that was not a straight line. I thought I'd selected a straight line tool. Take your line straight through them. It doesn't have to stop at them. And make it a bit fatter. There we go. Drag that down just a touch. Go straight through them. Same here. Ooh. I want to make that disappear. Okay, so there is our equation. Y equals 2x minus 1. All right, our next one, let's do that in green so it stands out a bit. We've got a gradient of -1/2 and a y-intercept of 3. So y-intercept of 3, 1, 2, 3 is up there. And then -1/2 just means that if it's rise over run, so rise over run, we can just go -1 over 2. That means it's going down 1 for every 2 it goes across. Okay, so it goes down 1 and 2 across. So we are out here for our second point. So it drops 2, goes across 1. Now for our straight line. And straight through there. Make it a bit bigger. And that's our equation. Y equals 3 minus x, sorry, x plus 2y equals 6 was the original equation. That's x plus 2y equals 6. Okay, you could express it as y equals -1/2 -x over 2 plus 3, but I just put the original equation in there. Hopefully that helps us all out with our sketching of graphs using the gradient intercept method. If you liked it, give it a thumbs up about the channel and have a great day. See you.